Alright, so we continue on our chapter of factoring. We've been factoring all sorts of ways. Let's review real quickly. First thing we did is we factored using the distributive law. Looked at a polynomial such as this and looked at the terms and tried to decide what's common among all of them that we could factor. The professional way would be to prime factorize 2 times x times x. And then 2 times 3 times x times x times x, and now you can see exactly what's common. What's common here is a couple x's and a 2, so we could factor that out. 2x x times 1. I could always do that by multiplicative identity. This is by natural exponents and times table. Here I have 2 times x times what's left over after I've taken that 2 out, that x and that x, there would be a 3 left and an x. This is by commutative law of multiplication, associative law of multiplication, among other things, and multiplicative identity on this one. Now I can see that 2x plus 1 is appearing on both of these, so therefore I could factor out a 2x times x. That leaves a 1 plus a 3 times x by the distributive law. That is, if I use the distributive law to distribute this there and that there, I would get exactly the previous line, leaving me with the new expression 2x squared 1 plus 3x. That right there is a very nice thorough way of explaining how we factored using the distributive law. We don't usually do it this way. This is only for beginners. Once you're comfortable with this, you can get from this step to that step by inspection. Anyways, that was one way to factor. The other way we factored was by grouping. And so by grouping, the grouping idea would go like this. You can first group those two and those two if you have 4 items. It also works for more, but we did it for 4. That's associative law of addition. That says you can group those. Out of these ones I could factor out an x squared, leaving x plus 1. I can always multiply by 1 using multiplicative identity. That way I have something left in there after I factor out of the x plus 1. The x plus 1 times 1 and the x plus 1 times x squared is the same thing as the x squared plus 1 quantity times the quantity x plus 1. It's easy to check. You could take this and distribute it in there. Again, the distributive law. Factor by grouping. Famous. We then proceeded to factor by splitting the middle term. You got one term, you got 3 items right here. 1, 2, 3. And you take that middle item and you make 2 out of it, and then you factor by grouping. So this is famous. It's called splitting the middle term. The key to it was you take that one and you take that one and you multiply them. The coefficient here is 1. So 1 times negative 5 is negative 5. You look at all the different ways to factor that. 5 times negative 1. Negative 5 times positive 1. And then you want them to add up to 4. These two add up to 4, so that's our winner chicken dinner. So I could take this and split up the middle term as a 5x and a 1x, and that would lead to a successful factorization by grouping, as we've done many times. Of course this was negative, so I have negative there. X plus 5. Again, check that when you distribute it, negative 1 times x gives you that. Negative 1 times 5 gives you negative 5. Always good to double check that you're doing good computations here. X plus negative 1 times x plus 5 by the distributive law. Yippee-ki-yay. Factor by splitting the middle term. Famous technique. If it can be factored using integers, this will successfully do it. You'll get a complete list of candidates, and that's it. If it can be factored, it's one of those. Again, I should always preface, if it can be factored using integers. Alright, that was fun. And then that's a little review what we've been doing lately. Now what? At some point or another you have to stop and say, what is the big deal with factoring? Why are we spending so many weeks and days and lectures factor this, factor that, factor by this, factor by... What the hell is the big deal with factoring polynomials?